Welcome to Review Central's Mathematics Proficiency Reviewer Drills, featuring drill questions on trigonometric identities. Mathematics proficiency is a typical subtest in many exams, including most high school and college admission and scholarship qualifying tests, some professional licensure and certification exams, and even some employment pre-qualifiers. If you are eyeing or are set to take any of these tests, then this reviewer is intended for you. There are 11 carefully curated questions featured on this reviewer. All questions are modeled on actual questions that appeared on various mathematics proficiency subtests. Before we proceed, don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Let's begin.
Drill question number 1. Sine beta times cosine beta times secant beta is equal to A. Sine beta, B. Cosine beta, C. Secant beta, D. Tangent beta, E. Cosecant beta. The correct answer is A. Sine beta. This is a very simple problem involving trigonometric identities. In fact, we need only a single trigonometric identity to solve it. Recall the trigonometric identity, cosine beta equals 1 over secant beta. This is one of the simplest and most commonly used trigonometric identities. After replacing cosine beta with 1 over secant beta, we can simply cancel out secant beta, leaving us with sine beta as our correct answer. There is an alternative and equally simple and just as fast solution to this problem. Instead of using the trigonometric identity, cosine beta equals 1 over secant beta, we use its reciprocal trigonometric identity, secant beta equals 1 over cosine beta. After replacing secant beta with 1 over cosine beta, we can simply cancel out cosine beta, leaving us with sine beta as our correct answer.
Drill question number 2. Simplify 3 sine squared theta plus 4 cosine squared theta. A. 7 plus cosine squared theta. B. 1 plus cosine squared theta. C. 3 plus sine squared theta. D. 3 plus cosine squared theta. E. 1 plus sine squared theta. The correct answer is D. 3 plus cosine squared theta. This is a very simple trigonometric identity problem that requires us to recall only one trigonometric identity in order to solve it. The first step is to express 4 cosine squared theta as 3 cosine squared theta plus cosine squared theta. For step 2, we simply group the first two terms together and factor out 3, as shown. And step 3, recall our Pythagorean trigonometric identity, sine squared theta plus cosine squared theta equals 1. Do you recognize that it is exactly the same as the expression inside the parentheses? Therefore, we can replace the expression inside the parentheses with 1, which leaves us with 3 plus cosine squared theta as our final answer. Very quick and easy, right?
Drill question number 3. Tangent x times sine x plus secant x times cosine squared x is equal to A. Sine x, B. Cosine x, C. Secant x, D. Cotangent x, E. Cosecant x. The correct answer is answer choice C, secant x. This is another simple problem involving trigonometric identities. Recall the basic trigonometric identity, tangent x equals sine x over cosine x. We substitute tangent x near the first term of the expression, and then combine the two sine x's, as shown. Next, recall another basic trigonometric identity, secant x equals 1 over cosine x. With this, we replace 1 over cosine x with secant x in the first term. We then factor out secant x from both terms, as shown. Next, recall the Pythagorean trigonometric identity, sine squared x plus cosine squared x equals 1. Using this, our expression will end up as secant x times 1, or simply secant x.
Drill question number 4. Negative tangent minus alpha times cotangent minus alpha is equal to A. Tangent alpha, B. Cotangent alpha. C. 1. D. minus 1. E. Negative tangent alpha times cotangent alpha. The correct answer is D. minus 1. Recall the trigonometric identities for opposite angles: tangent minus alpha equals minus tangent alpha, and cotangent minus alpha equals minus cotangent alpha. We substitute these to our given expression as shown. Next, we recall the trigonometric identity: cotangent alpha equals 1 over tangent alpha. We also substitute this to the expression as shown. We end up with a minus tangent alpha multiplied by 1 over minus tangent alpha. We simply cancel out the minus tangent alphas, and should end up with minus 1. Alternatively, we could have used the trigonometric identity, tangent alpha equals 1 over cotangent alpha in step 2, and we'll have ended up with the same correct answer.
Drill question number 5. 1 plus tangent squared theta is equal to A. Cotangent squared theta. B. Sine squared theta. C. 2. D. Cosine squared theta. E. Secant squared theta.
The correct answer is E. Secant squared theta. This trigonometry problem was modeled on an actual question that appeared on the Mathematics Proficiency subtest of a college entrance test. First, recall from trigonometric identities that tangent theta equals sine theta over cosine theta. Therefore, tangent squared theta must be sine squared theta over cosine squared theta. 1 plus tangent squared theta can therefore be expressed as 1 plus the quantity sine squared theta over cosine squared theta. With cosine squared theta as the least common denominator, we can rewrite the expression as cosine squared theta plus sine squared theta, all over cosine squared theta. Again, recall from trigonometric identities that sine squared theta plus cosine squared theta is equal to 1. This is known as a Pythagorean trigonometric identity because it is based on the Pythagorean formula. Therefore, our expression can now be expressed as 1 over cosine squared theta. Finally, recall again from trigonometric identities that 1 over cosine theta equals secant theta. Therefore, 1 over cosine squared theta must be equal to secant squared theta. There is a shorter and much faster alternative solution to this. Earlier in our first solution we introduced what is known as a Pythagorean trigonometric identity. There are actually 3 Pythagorean trigonometric identities, and what we introduced earlier is just one of them. The 3 Pythagorean trigonometric identities are 1. Sine squared theta plus cosine squared theta equals 1. 2. 1 plus tangent squared theta equals secant squared theta. And 3. Cosecant squared theta equals 1 plus cotangent squared theta. As you can see, the second Pythagorean trigonometric identity is the immediate solution to our given problem. So if you know your Pythagorean trigonometric identities, then you can potentially save a lot of time by skipping all the steps we went through in our first solution.
Drill question number 6. The quantity 1 minus cosine squared x over tangent squared x plus 2 times sine squared x is equal to A. 1 plus sine squared x. B. 1 plus cosine squared x. C. 1 minus tangent squared x. D. Tangent squared x minus 1. E. Sine squared x. The correct answer is A. 1 plus sine squared x. Step 1. Recall the Pythagorean trigonometric identity, sine squared x plus cosine squared x equals 1. This can be rewritten as sine squared x equals 1 minus cosine squared x. Let's substitute this into the numerator of the first term, as shown. Step 2. Recall the trigonometric identity, tangent x equals sine x over cosine x. Let's use this to substitute tangent squared x in the denominator of the first term, and then resimplify the first term, as shown. From here, we can see that we can cancel out sine squared x from the first term. We then use the same Pythagorean trigonometric identity that we used in step 1 to replace cosine squared x. Our expression should now read as 1 minus sine squared x plus 2 sine squared x. After adding like terms, our final answer should be 1 plus sine squared x.
Drill question number 7. The quantity cotangent lambda plus tangent lambda over secant minus lambda is equal to A. Sine lambda, B. Cosine lambda, C. Tangent lambda, D. Secant lambda, E. Cosecant lambda. The correct answer is E. Cosecant lambda. First step is to recall our trigonometric identities for opposite angles. Secant minus lambda is equal to secant lambda. Next, let's recall the trigonometric identities. Cotangent lambda equals cosine lambda over sine lambda, and tangent lambda equals sine lambda over cosine lambda. Let's substitute cotangent lambda and tangent lambda into our expression as shown, and then let's simplify the resulting fractions in the numerator by getting their least common denominator. From our Pythagorean trigonometric identity, we can replace sine squared lambda plus cosine squared lambda with 1. Recalling our trigonometric identity, secant lambda equals 1 over cosine lambda, we replace secant lambda in the denominator and then simplify the resulting fraction, as shown. We should end up with 1 over sine lambda. And finally, let's recall from our trigonometric identities that 1 over sine lambda is equal to cosecant lambda.
Drill question number 8. Express the quantity 1 over sine theta times cosine theta minus cotangent theta in terms of cotangent theta. A. Tangent theta, B. Cotangent theta, C. 1 over cotangent theta, D. 1 minus cotangent theta, E. Cotangent squared theta. The correct answer is C. 1 over cotangent theta. It is clearly specified in the problem that the given expression be expressed in terms of cotangent theta, so we can immediately eliminate answer choice A. Recall that cotangent theta is equal to cosine theta over sine theta. Let's substitute this in the second term as shown. We can then express the two terms in terms of their least common denominator as shown. But from our Pythagorean trigonometric identities we know that 1 minus cosine squared theta is equal to sine squared theta. Let's substitute this into the numerator. We can then cancel out sine theta from the numerator and the denominator, leaving us with sine theta over cosine theta. We already know from our trigonometric identities that sine theta over cosine theta is equal to tangent theta. This would have made answer choice A the correct answer, except that it was specifically stated that the answer should be expressed in terms of cotangent theta. Of course, tangent theta equals 1 over cotangent theta, so our final answer should be 1 over cotangent theta.
Drill question number 9. Simplify the quantity secant A plus cosecant A times the quantity sine A plus cosine A minus 2 minus cotangent A minus 2, B. Cotangent A, C. Sine squared A, D. Tangent A, E. Cotangent squared A. The correct answer is D. Tangent A. Does this long expression intimidate you? Don't be. Except that it is indeed relatively long, it isn't really that complicated. First, using the distributive property of multiplication from our basic algebra, let's multiply and expand the terms inside the two parentheses. Next, recall our trigonometric identities, secant A equals 1 over cosine A, and cosecant A equals 1 over sine A. Let's substitute these as shown. Next, we recall our trigonometric identities, tangent A equals sine A over cosine A, and its reciprocal, cotangent A equals cosine A over sine A. We again substitute these to our given expression as shown. From the resulting expression, we simplify further by cancelling out +1 and +1 with -2, as well as cotangent A with minus cotangent A. What is left is just tangent A, which is our correct answer.
Drill question number 10. Give the simplest form of the quantity tangent square theta minus sine squared theta over the quantity tangent squared theta times sine squared theta. A. Sine theta, B. -1, C. 0, D. 1, E. Tangent theta. The correct answer is D. 1. This problem was modeled on an actual question that appeared on a previous UP college admission test or UCAT. First, we simplify the given expression by splitting it into two separate fractions and canceling out common terms. We should end up with a simplified expression, 1 over sine squared theta minus 1 over tangent squared theta. Next, we recall from our trigonometric identities that 1 over sine theta is equal to cosecant theta, and 1 over tangent theta is equal to cotangent theta. Therefore, our expression should now be equal to cosecant squared theta minus cotangent squared theta. We also recall the Pythagorean relationship of cosecant and cotangent as follows. 1 plus cotangent squared theta equals cosecant squared theta. Rearranging this Pythagorean relationship a bit will result to cosecant squared theta minus cotangent squared theta equals 1. Therefore, our given expression, which we have so far simplified into cosecant squared theta minus cotangent squared theta, can be further simplified to simply equal 1.
Drill question number 11. If alpha equals secant x, beta equals sine x, and lambda equals cotangent x, then the quantity lambda over alpha, all over the quantity 1 minus beta squared, is equal to a. Cotangent x times cosine x, b. Cosecant x, c. Sine cubed x, d. 1 over cosecant x, e. 1 over the quantity sine x times cosine squared x. The correct answer is B. Cosecant x. This trigonometry problem was modeled on an actual question that appeared on the Mathematics Proficiency subtest of the ADMU College Entrance Test or ASET. Here's our solution. Step 1. Substitute alpha, beta, and lambda values in lambda over alpha, over the quantity 1 minus beta squared. Step 2. Recall the trigonometric identities, cotangent x equals cosine x over sine x, and secant x equals 1 over cosine x, and substitute into the given expression, as shown. Step 3. Do you still recall the Pythagorean trigonometric identity, sine squared x plus cosine squared x equals 1? This can be expressed as 1 minus sine squared x equals cosine squared x. Again, substitute into the given expression as shown. Step 4. We can cancel out cosine squared x, leaving us with 1 over sine x. Step 5. Again, recalling from our trigonometric identities, we know that cosecant x equals 1 over sine x. Therefore, our correct and final answer is cosecant x.
And here is the summary of the trigonometric identities that we have used in this drill for your quick reference. Instead of just listing down here the trigonometric identities that we used on this drill, let us present them to you in the trigonometric identity categories they belong to. For uniformity and easier recall, we will use theta as the name of the angles for all the trigonometric identities that we will be presenting in this summary, although other names of angles may have been used on the actual questions where these trigonometric identities have been used in. First are the reciprocal trigonometric identities. There are 3 of these and we've repeatedly used them in almost all of the preceding drill questions that we have presented. Next are the ratio trigonometric identities. There are 2 of these, which are actually just reciprocal of each other. We have also used them extensively in our preceding drill questions, particularly in questions 3, 5, 6, 7, 8, 9, and 11. The third category of trigonometric identities that we have used in the preceding questions are what are known as Pythagorean trigonometric identities, because they are based on the Pythagorean formula. We've extensively used the first of these Pythagorean trigonometric identities, particularly in drill questions 2, 3, 5, 6, 8, and 11. We've used the second one in solution 2 of drill question number 5. And we've used the third one in drill question number 10. The last category of trigonometric identities that we have used in the preceding questions are the trigonometric identities of opposite angles. These are even more seldom used, but we've seen them in a few mathematics proficiency exams, so we might as well prepare for them. They are a bit tricky to remember though, because they involve chiefly the placement of the negative signs. What you should remember is that, of the 6 trigonometric ratios, only cosine and secant are unaffected by a negative angle. The rest of the ratios are similarly affected by a negative angle as shown. Please take note that there are dozens more of other trigonometric identities that we have not covered on this drill. We featured only those that you are most likely to need in your math proficiency exams. If you wish to learn other trigonometric identities, you may check out some links that we have included in the description below. If you have the time to spare, we do encourage you to learn more trigonometric identities. You'll never know if and when you'll need them in your future mathematics proficiency tests.
To wrap up our mathematics proficiency drill on trigonometric identities, let's quickly discuss some important notes for you. First, trigonometric identities very seldom appear on math proficiency tests. Having said that, they do appear from time to time, so it is prudent to sufficiently prepare for them, just in case. If and when they do appear on math proficiency tests, there won't be a lot of them. In most cases, there'll just be 1 to at most 2 trigonometric identity questions in a typical 50 to 100 question test. In many cases, trigonometric identity questions that appear on mathematics proficiency exams are very simple ones. Usually they are just a test of your basic knowledge of the trigonometric identity concepts and a few of the more common trigonometric identities, such as the ones we featured on this drill. Mathematics proficiency tests that are known to feature trigonometric identities include mostly college entrance tests, such as the UPCAT, ASET, and PUPSET. But of course there is no guarantee that they will not appear in other exams, so it is always better to prepare for them. Especially in highly competitive exams, where you are going to compete for limited admission or qualification slots with hundreds or even thousands of other examinees, having prepared for topics that seldom appear when most other examinees have not, can be your unique competitive and strategic advantage.
You have just watched Review Central's Mathematics Proficiency Reviewer Drills, featuring drill questions on trigonometric identities. By now you should be ready to take on any mathematics proficiency test featuring trigonometric identities. The drill questions we featured in this particular episode have been carefully curated to present to you as many of the typical trigonometric identity questions that appear on mathematics exams. If you wish to watch more Mathematics Proficiency Reviewer Drills, check out our Mathematics Proficiency Reviewer Drills playlist. Check out also our other reviewer drill playlists for other topics. If you haven't done so yet, please don't forget to subscribe to Review Central, and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Please like if you find this video useful, and feel free to share to anyone who may also benefit from it. We wish you all the best on your forthcoming exam.